I will do the introduction for the third session regarding energy efficiency, gas, hydrogen, and AI in English. But all our colleagues could present also in Greek if they like. As the global economy undergoes rapid transformation, innovation remains the cornerstone of sustainable growth. This session explores how sectors such as energy efficiency, natural gas, hydrogen, and artificial intelligence are converging to create new value chains and accelerate the energy transition. These technologies are not only changing the way energy is produced and consumed, they are reshaping entire industries and creating opportunities for bold long-term investments. Recent research highlights that breakthrough innovations, whether in products, processes, experiences, or business models, tend to emerge from willingness to act boldly, embrace technology, and rethink customer engagement. In the energy sector, these principles are manifesting through digital optimization of infrastructure, AI-driven maintenance and forecasting, and the integration of hydrogen as a clean energy vector are key players. The key to unlocking the full potential of these innovations and technological changes lies in leadership mindsets. Companies that outperform their peers often do so by prioritizing long-term growth over short-term gains, investing in talent, and cultivating a culture of experimentation and customer centricity. Especially in volatile times such as those that we are facing those years, it's those organizations that dare to invest, adapt, and collaborate across boundaries that emerge stronger after time. As we begin this session, our distinguished speakers will provide diverse perspectives from technological innovation and operational excellence to research-driven strategies and market dynamics. Together, we will explore how efficiency, digitalization, and clean energy can become the foundation of a more resilient, inclusive energy future. With us today are Mr. Michalis Pieretis, Chief Commercial Officer of QNR Greece, Dr. Konstantinos Balaras, Research Director of the National Observatory of Athens, Dr. Alexandros Papaspiridis, through online connections of Nefos, Manager Director of Nefos Consulting, Mr. Paris Franceskakis, Senior Manager, Technical Department from DESFA, Dr. Nikolaos Koukouzas, Director of Research of the Center of Research and Technology, and Dr. Nikos Patsoules, Independent Energy Advisor from IENE, who is IENE's partners. So, Mr. Pieretis, the floor is yours. Please allow me to add that since Mr. Pieretis has an unprecedented meeting at 3 in the city center, he has to leave by 30, 2:30. Okay, thank you.
Σας ευχαριστώ κύριο Τόσιο για την πρόσκληση. Θα μιλήσω λίγο από την πλευρά του integrator σήμερα, από την πλευρά του υλοποιητή των έργων. Θα περάσω λίγο γρήγορα την εταιρεία για να κάνω introduce κάποια έργα που έχουμε κάνει και θα κάνω focus στο κομμάτι του asset management. Μου έχει δώσει μια πάρα πολύ ωραία πάσα, χωρίς να το γνωρίζουμε, ο κ. Ελευθεριάδης από τη Deloitte, οπότε θα συνδυάσουμε λίγο τις τεχνολογίες. Η QNR... Η QNR πλέον group εταιριών. Η QNR ξεκίνησε την πορεία του το 1992, το 2000 εισήχθη στο χρηματιστήριο. Είναι ένας από τους σημαντικότερους custom software integrators στην Ελλάδα, με το τελευταίο διάστημα, λόγω κυρίως του Ταμείου Ανακάμψεως, να υλοποιεί και να συμβασιοποιεί ένα τεράστιο αριθμό έργων, κυρίως στην κεντρική κυβέρνηση, σε πάρα πολλά έργα τεχνολογίας και καινοτομίας. Μάλιστα πρόσφατα, χθες νομίζω, δημοσιοποιήθηκε η παραλαβή του flagship έργου που έχουμε κάνει στο ελεγκτικό συνέδριο με χρήσης AI. Το γκρουπ εταιριών μας πλέον μέσα από το πλάνο ανάπτυξης που έχουμε κάνει και που έχουμε καταθέσει περιλαμβάνει εταιρείες του χώρου του cyber security μέσω εξαγοράς, η Systecom, περιλαμβάνει εταιρείες του χώρου του AI, της Square Dev, ελληνοβελγικών συμφερόντων, η QNRFS, Financial Services, και έχουν ανακοινωθεί και κάποιες επόμενες εξαγορές που θα γίνουν πάντα στο μέτρο της τεχνολογίας, στο κομμάτι του ERP, στο κομμάτι του Defense Technology και Space Technology. Οι κύριες δραστηριότητες που καλύπτει η εταιρεία μας είναι προφανώς το e-government, στο οποίο έχουμε ένα πάρα πολύ μεγάλο αριθμό έργων που έχουν εκτελεστεί και εκτελούνται αυτή τη στιγμή. Gen AI, αυτή τη στιγμή, νομίζω μέχρι και σήμερα, είμαστε η μοναδική εταιρεία που έχει εκτελέσει και έχει πάρει πρωτόκολλο παραλαβής έργου στο δημόσιο βασισμένο πάνω σε τεχνολογίες AI, αμιγώς as such AI, όχι και AI ή ένα απλό chatbot, ένα πολύ μεγάλο έργο στο Υπουργείο Εξωτερικών, το οποίο είναι βασισμένο σε τεχνολογίες IBM, και αυτή τη στιγμή υλοποιούμε άλλα 2 πάρα πολύ μεγάλα έργα βασισμένα as such σε τεχνολογίες AI. Business Automation και Workflow, Asset Performance Management και IoT, θα το εξηγήσω αργότερα, δεν αναπτύσσουμε κάτι εκεί, κάνουμε customize τεχνολογίες IBM, το κομμάτι του Maximo, Cyber Security, Big Data και FinTech. Θα περάσω λίγο γρήγορα κάποια use cases που έχουμε εκτελέσει. Αυτή τη στιγμή εκτελούμε ένα έργο στην Gas Trade, του Μήλου Κοπελούζου. Αυτή είναι μία λύση η οποία είναι βασισμένη σε AI και σε AI μάλλον, η οποία αυτοματοποιεί την κατηγοριοποίηση και την αναζήτηση περιεχομένου σε φυσική γλώσσα, ώστε να μειωθεί η φυσική διακίνηση εγγράφων λόγω της δυσκολίας που έχει η εταιρεία η Gas Trade στο έργο που υλοποιεί το FSRU στην Αλεξανδρούπολη για την επαναεροποίηση. Οπότε εκεί υπήρχε κάποιο task που έπρεπε ουσιαστικά να ψηφιοποιηθούν όλες οι ροές εργασίας και να προσφερθεί ασφάλεια ακόμα και σε κάποια έτσι λίγο πιο εμπιστευτικά έγγραφα. Θα γυρίσω εδώ. Το δεύτερο έργο είναι το Modesto, νομίζω είναι και στο site του ΑΔΜΙΕ αυτό. Είναι ένα πληροφοριακό σύστημα το οποίο βοηθάει στον ανασχεδιασμό των επιχειρησιακών διαδικασιών και λογισμικών επεξεργασίας και επιστοποίησης των μετρήσεων και υπολογισμών εφαρμογών του ισοζυγίου για τις εφαρμογές αγοράς εξορρόπησης ενέργειας. Είναι έργο το οποίο το έχουμε υλοποιήσει, το έχουμε παραδώσει και αξιοποιείται κανονικά από τον οργανισμό. Το APMS είναι ένα το οποίο ακόμα εκτελείται, είναι βασισμένο πάνω στο Maximo της IBM, γιατί αυτό το έχω αφήσει και τελευταίο. Ουσιαστικά, μαζί σε συνέργεια με κάποιες άλλες εταιρείες, εμείς υλοποιούμε το κομμάτι του Asset Performance Management, όπου εδώ εγκαθίστανται κάποιες συγκεκριμένες μονάδες, κυρίως σε μη επανδρωμένους, αλλά και επανδρωμένους σταθμούς του οργανισμού, του ΑΔΜΙΕ. Το Maximo συλλέγει όλη την πληροφορία που χρειάζεται για να μπορέσει να έρθει στα κεντρικά και μέσα στα σκάντα για να γίνει οι κατάλληλες ενέργειες, η παρακολούθηση και το preventive maintenance. Τι είναι το Maximo? Θα μιλήσουμε κυρίως για τον ενεργειακό τομέα που μας ενδιαφέρει προφανώς σήμερα. Οι επιχειρήσεις καλούνται να αντιμετωπίσουν σύνθετες προκλήσεις, όπως είναι η φθορά του εξοπλισμού, οι αυξημένες απαιτήσεις ασφάλειας και φυσικά η αποχώρηση έμπειρων τεχνικών. Η τεχνολογία μπορεί να προσφέρει λύσεις ενισχύοντας την αξιοπιστία, μειώνοντας το κόστος και προλαμβάνοντας αστοχίες πριν αυτές συμβούν. Η πορεία διαχείρισης των περιουσιακών στοιχείων περιλαμβάνει κυρίως 5 στάδια. Τη διαχείριση, την παρακολούθηση, την ανάλυση της υγείας, την πρόβλεψη και την επιθεώρηση. Κάθε στάδιο αξιοποιεί δεδομένα και τεχνολογίες AI και από IoT sensors προφανώς, για να μετασχηματίσει λειτουργίες συντήρησης και να μεγιστοποιήσει τη διάρκεια ζωής των υποδομών. Το Maximo Application Suite περιλαμβάνει μια ολοκληρωμένη λύση ALM, Asset Lifecycle Management, η οποία τι περιλαμβάνει? Περιλαμβάνει το παραδοσιακό Enterprise Asset Management, το EAM, και έχει προσθέσει το APM και τις AI-driven εφαρμογές, έτσι ώστε να παρέχει δυνατότητες αυτοματοποίησης και ανάλυση δεδομένων για διάφορους κλάδους. Οι βασικές λειτουργίες της πλατφόρμας περιλαμβάνουν διαχείριση έργων και εξοπλισμού, εφοδιαστική αλυσίδα, mobility, περιβαλλοντική ασφάλεια, αναλυτικά εργαλεία και χρονοπρογραμματισμό. Όλα αυτά ενοποιούνται σε ένα εργαλείο, σε μία πλατφόρμα που διευκολύνει τον ολοκληρωμένο έλεγχο του Asset Life Cycle. Θα δείξουμε κάποιες εικόνες για κάποια υποσυστήματα εδώ. Το συγκεκριμένο είναι για τη χωρική πληροφορία, η οποία επιτρέπει την οπτικοποίηση κρίσιμων στοιχείων υποδομής ακριβώς στο γεωγραφικό τους χώρο. Μέσω της ενσωμάτωσης των GIS δεδομένων μπορούν να γίνονται πιο στοχευμένες και οικονομικά αποδοτικές παρεμβάσεις συντήρησης και αξιολόγηση κινδύνου. Η ενότητα Health παρέχει μια εικόνα κατάστασης υγείας του όποιου εξοπλισμού, βοηθάει στη μείωση της περιττής συντήρησης, στη λήψη αποφάσεων αντικατάστασης και στην αύξηση της διαθεσιμότητας των assets μέσω ολοκληρωμένης παρακολούθησης και προληπτικής δράσης. Η προβλεπτική συντήρηση βασίζεται σε μοντέλα ανάλυσης αστοχίας, ενσωματώνοντας δεδομένα αισθητήρων και τεχνητής νοημοσύνης. Με αυτόν τον τρόπο μειώνονται οι βλάβες, περιορίζεται το κόστος, αυξάνεται η παραγωγικότητα και επιμικρύνεται η ζωή των assets. Πολλές φορές παρατηρούνται και επιθεωρήσεις με χρήση AI drones και αισθητήρων, οι οποίες προσφέρουν μια ταχεία και ακριβή ανίχνευση ελαττωμάτων, όπως για παράδειγμα εδώ, που είναι μια εφαρμογή στη χρήση θερμογραφίας για τον εντοπισμό απολειών σε φωτοβολταϊκά. Η οπτικοποίηση με θερμικά δεδομένα και σύνδεσή τους με μοντέλα και 3D προσφέρουν αναλυτική κατανόηση και άμεση παρέμβαση σε κρίσιμα σημεία. Τέλος, το IBM Maximo για ανανεώσιμες πηγές ενέργειας ανταποκρίνεται στις ειδικές προκλήσεις του κλάδου, παρέχοντας εργαλεία για παρακολούθηση απόδοσης, ανάλυση δεδομένων και βελτιστοποίηση λειτουργιών. Είναι η απάντηση στη διαρκώς αυξανόμενη ανάγκη για βιώσιμη και αποδοτική παραγωγή ενέργειας. Ευχαριστώ πολύ.
Επειδή ο χρόνος σας είναι περιορισμένος, εγώ, εντάξει τώρα και εξιστορίας...
Εκτός προγράμματος.
Ναι, όχι, εξιστορίας σε αυτά που έβλεπα, έτσι θυμάμαι έτσι καλές ιστορίες από τη διαχείριση και τη συντήρηση των υποδομών. Το βασικό ερώτημα πάντα σε αυτές τις περιπτώσεις είναι ότι καλά προχωράει η τεχνολογία. Προφανώς όσο πέραν τα χρόνια η πληροφορία θα έχετε πιο γρήγορα, για να μπορούμε να παίρνουμε και καλύτερες αποφάσεις, ας πούμε, να μην έχουμε φαινόμενα όπως καλή ώρα ζήσαμε όλοι το φαινόμενο της Ισπανίας. Το ερώτημα μου πάντα σε αυτά είναι, βρίσκεται πρόσφορο έδαφος όταν πάτε στις εταιρείες για να τα ξεκινήσετε? Το budget, ας πούμε, υπάρχει θεωρητικά.
Ναι.
Και ποιες είναι οι δυσκολίες?
Νομίζω οι δυσκολίες είναι προφανώς το κόστος. Νομιζόμενοι φορείς ότι όλα αυτά τα έργα έχουν ένα τεράστιο κόστος. Εμείς πάντα το προσεγγίζουμε ανάποδα, δηλαδή βλέπουμε ποιες είναι οι προτεραιότητες του φορέα, του εκάστοτε φορέα και ποιος είναι ο προϋπολογισμός, για να δούμε ποια κρίσιμα σημεία μπορούμε να καλύψουμε. Νομίζω όμως ότι όσον αφορά το πρώτο σκέλος ερώτησης, νομίζω ότι πλέον οι οργανισμοί έχουν αρχίσει να εξοικειώνονται με τις τεχνολογίες αυτές. Προφανώς το AI είναι κάτι πάρα πολύ καινούριο, όλοι το συζητάμε, υπάρχει ένα τεράστιο gap, κανένας μας δεν γνωρίζει την ακριβή ανάγκη του τι θέλουμε να κάνουμε, οπότε πάλι εκεί ξεκινά μια συζήτηση, μια ορίμανση, αλλά ναι, νομίζω ότι ο κόσμος έχει ξεκινήσει και εξοικειώνεται με τις τεχνολογίες και την ανάγκη να χρησιμοποιήσει τέτοιου είδους συστήματα.
Επειδή ο κύριος Πιερέτης πρέπει να αποχωρήσει εκτάκτως, όπως είχα πει, έχει κάποιος κάποια ερώτηση από το κοινό μας? Ωραία. Ευχαριστούμε.
Ευχαριστώ πολύ. Καλή συνέχεια.
Καλώ στο βήμα τον κύριο Κωνσταντίνο Μπαλαρά, τον δόκτωρα Κωνσταντίνο Μπαλαρά, για τη δική του παρουσίαση.
Great. Μπορούμε να ανεβάσουμε. Wow. All right. So it's there. Thank you very much. It's a great pleasure being here today. And I had the opportunity to join the event from the beginning. And I enjoyed every presentation. But putting myself in the position of we have at least one non-Greek speaking guest here. I said, I'm just going to speak in English to honor his presence here, to make it a little bit easier for him to understand. And I hope it's clear enough for everyone in the audience. So I come from a research organization. It's actually the first national research organization in Greece. And over the past, it's about 30 years, I've made a career there. I've worked as a mechanical engineer, but in terms of my research work, that's where I had the honor of serving. We have been working on energy conservation. And if anything, I'm going to just make that as a closing statement at the end. I think it has been, it is, and should continue in the future be our primary objective, primary goal. And overall, I think this event, in terms of saying, well, what's really the innovative, the new, the groundbreaking in energy, I'm just going to put a twist in the approach. Well, saying that, indeed, I'm going to be focusing on where the major part of the problem with regard to energy is, and that's the building. That's the built environment. The buildings have been at the center stage for decades now, and they continue to play a key role. That's one of our big challenge. 40%, let's make it about half of the energy, our topic, goes to serve the buildings. Well, actually, the buildings are just there. It's serving us, living and working. So it's all about us, our comfortable indoor environment, the services, the operation, everything that we do requires energy. And before I forget, Mr. Theophylakis posed a very important question earlier this morning. If you were here, you heard it. He said, so if the internet goes down, boy, we're in trouble. Yes. He didn't get a clear response, but I'm just going to say yes. The same way that with everything else, more and more we're talking about the electrification, that's also going to be part of the problem, of the challenge that we're going to be facing, because if the grid goes down, it just happened in Spain and Portugal, everything stops. And I was there. I was boarding the plane in Madrid when, poof, everything went down. And I thought it was something with the Tower Bridge connecting to the plane, didn't pay much attention. But sure enough, said, we cannot go anywhere. The plane had engines running, right? It wasn't doing, but the bridge wouldn't really go back, so the plane couldn't move from there. So you see, everything directly depends on that. And up to now, from the engineering point of view, if you're in design, construction, you had it easy, quote unquote, because you had a problem, the building. Well, now, this is the boundaries I keep growing to a larger area, the neighborhood, to a larger area, the city, and more, as we heard this morning, to the region, to the country, to the continent. And that adds to the complexity. So, we're having challenges, but at the same time, we have opportunities. So that's really the good thing about all these different facets of the problem that we're looking, that are always opportunities that we should be focusing on. And as we have done with, you see on the top of the screen there, I have new buildings, the new problems. We're doing pretty well. I have a check mark there saying that we have new regulations, our new buildings are being constructed, energy efficient, lower energy demand, and all the goodies there. So that's, and we're talking for tomorrow, practically tomorrow, we're going to have net positive. So the buildings are transforming from the problem to being part of the solution. So not only demanding energy, but actually producing excess and giving back, serving us and then giving back to one form of the grid, electric, or sometimes may even be thermal. But where should we be focusing? Where is now where we need to put our finger and say, well, this is the problem? Well, the problem is with the existing. That's the big challenge we're faced, whether you are, again, the engineering profession, even in a political decision-making position. That's where your problem is with the existing, because we're talking about millions of buildings, billions of square meters of floor area. Huge investment in money, well, not only architectural heritage, value, societal value, all this, huge investment. So even if we had the money, which is a critical element in everything that we discuss, to say, shh, demolish it, everything's gone, let's rebuild, it is practically impossible. So that's where our big challenge is. And then the opportunities come, because then we start looking at what we can put together. What remains a pillar, and I'm happy to say that, well, you may have different opinions about the European Commission, but one thing that has remained at the center stage, a pillar in all the policies and all the efforts, is this: energy efficiency first. I don't care where you're going to get your energy. That is and should be in the future our first priority. I got a little bit concerned before the lunch break when I saw in the presentation increased energy demand. And I went, what did he say? Increase energy demand. I understood he was talking about, well, increase the electricity, because we're talking about generating from renewables. Renewables want the loads to keep them balanced. And then I said, oh, okay, I got it. But still, I feel that the concluding remark, increase electrification, was a better statement, which is actually happening. But at the same time, we always need, because it makes financial sense to, no matter where you're going to get your energy from, conventional, we should know that because we're paying for it, or renewables, supposedly the free energy, is always a cost to it, or any other form of energy, it's going to take investment. So you cannot keep growing your demand, your consumption, because financially it's not going to be viable. And then I said, okay, am I done with this slide? I wanted to really put something as a message. I just want to make sure I just give you some key points here, some key takeaways. And I put the big M there. The big M that has two components, massive, and I think I explained this when I was referring to the millions of buildings, the billions of floor spaces. This is massive. So it cannot be one new building in this neighborhood and another new building that we all go by and say, wow, that's a nice new building in the next neighborhood in the next city. This is not going to do it. We have to see all our building stock transformed. So that is going to take a massive effort. Of course, massive opportunities for the market, the engineers, the producers, whatever. And then I have that other big M word, the mandatory. I had an interesting discussion preparing for this with Mr. Staboulis. We talked on the phone and said, and I tried to communicate, and I think he understood what I was trying to say. He said, interesting, that over the decades, what I have been experiencing, at least in our little cosmos here of the building sector, which is important, that we have so much innovation. The market, the technologies have advanced, but at the same time, they have been there for decades. But it hasn't been mandatory to use them. So there is, and I know we can engage in a large conversation. We don't want mandatory laws, regulations. The market can react. Sure enough, but you know what? It helps. It pushes the market in the right direction. So I'm a firm believer, and I can give you an example with the regulations. You'll remember back in 1980, where we had our first thermal regulation in Greece to install thermal insulation. Wow, what a breakthrough concept. Yeah, well, it was 1980, if you recall, the first. And it was so good, perfect regulation, that we kept it for 3 decades, 30 years. Nothing changed. After 30 years, we figured out, again, the heat transfer, and some engineers did the calculations. Not really. Everybody, but we were arguing. If you were in the market, if you were an engineer before and you were in the market, you were arguing with your client, can we go add more insulation? How much is it going to cost? And then finally, as a result of a European directive, that started back in the early 2000s, EPPD, the Energy Performance of Building Directive. We had, the era of KENAC, the new regulation. And all of a sudden, that's all it took. No innovation, no breakthrough, just simple, common engineering sense that you have to protect your thermal envelope before you do anything else. Now, the EU regulations are the first step. Sometimes this is the stricter, sometimes they're just directives that tell the member states, this is the path. This is how we're going to go forward. They don't tell you exactly how. It's up to the member states. It's up to us. So finally, that's what is very important to remember. We need a national law to enforce it. And once that is done, even we need more. We need the tools. We need the guidelines, the technical guidelines, in order to be able to enforce them in practice on our daily routine. There's a plethora of these directives and regulations from the higher level up. Sometimes, I'm going to tell you a little secret here, it may be confusing. Yeah, because there's just not one, there's just multiple, because it is a complex problem we're trying to approach. And we should keep in mind, there is not one path. You see, there are different elements. That's the big picture. Do not focus on one of them and say, well, you know, Renewable Energy Directive, RED, is the solution. No. Why? You see it. It's only part of how we're going to solve this puzzle. So it's only one element. If it doesn't have all the others, it's not going to work. So when one focuses on, for example, renewables and says, this is not going to work, this is not going to, sure it's not going to work by itself. Of course it will not, it will fail. But this is not only of that. So then you need to enforce. And in Greece, you know, this is a very, very important part of the success story. Unless you enforce it, just having the legislation, even the law, doesn't mean much. And then implement and knowledge and the tech solutions. We have so much innovation already in our hands. Let's use it. The technology there is there. What is challenging? How do we measure success? Is this: select the most appropriate. That's up to us. That's up to the engineers, the experts, out of this long list to be able to come with the most effective. So the innovation here for me is to make sure out of this library of available solutions to pick up for your own unique project, unique building, the most appropriate ones. And then we need the supporting actions and finance. Yes, sometimes it all comes down to this financing, new tools, new schemes in order to help. And of course, the tools for the engineers are essential, mandatory in order to be able to do it easily on our daily projects. I have the luxury of being in a research organization. I can spend a month studying a building. An engineer like Costa Felix there, he has a few days in order to, get his project running, going. He needs to move on. So he needs practical tools that are essential in order to support this. What is coming up in terms of, I think, another takeaway? We talked so much and we heard so much about automation controls. Well, already the Commission is working on a new assessment. It's the Smart Readiness Indicator for buildings. It's going to be something like, and part of the energy audits, part of the energy performance certificate. It's going to be linked, coupled to that. This is in the pipeline for several years now. It's in the final stages, and it actually builds on what we're talking, that the building becomes part of the system. So it needs, with especially the grid, interact, and that is going to be one of the measures to facilitate in the assessment and in the design. The other, of course, is that, as I said, and I like this visual there because it gives you all the different elements, issues that now the building is at the center stage because it interacts with the grid. So first, it needs to be efficient, it's connected, it's smart, and it's flexible in order to be able not only take from the grid, but also give back to the grid. So it means that it has to control its operation. And to make sure that I don't leave the impression, that's pretty easy, okay, I can do that. Well, it's not just the building now, it's the city. So the whole city needs to and become smart. And smartness of a city, it's not just installing Wi-Fi and 5G. It's a lot more. So there are different, again, elements that need to be considered. And that kind of like completes the process. In conclusion, I was trying to kind of like leave the big message. I'm glad I don't have to say much because we heard about so much about cybersecurity, because once you start interacting with the grid, this is a delicate balance that you need to keep, but also it includes a lot of personal information. So that, and in addition to the sensitivity that if it goes something wrong, you cannot say, oops, let me correct. If you say, oops, the whole thing collapses. Probably what happened in Spain protocol. The communication protocols are there. Equipment speak, and we better listen because our installations speak. And also, we can communicate with them. We don't speak exactly in English, but there are communication protocols, even between the equipment. The market, the industry has advanced. So equipment from manufacturer A talks with equipment from manufacturer B. That was not possible in the past. So you can select the best of the best, and they talk to each other so that they can talk to the main controller, to the brains of your system. And a key message at the end, please try to keep it simple. That will make things so much easier. And once we live here and we say, God, we got some brilliant ideas, things are going well. Well, yeah, we're thinking globally, but when we go home or at our office, let's try to do our share, because that's all where it starts from, doing our own share. Thank you.
Thank you, Dr. Bararas. One quick question from me, and if one of the audience can ask you something, we have time. Do you believe that we have policies on a European or national level for smart readiness?
Yes, we do. And this methodology that is being developed, and I said again, it's maturing, and it's going to come out as we speak. It's being tested, including in Greece. The methodology is there. So how are we going to do it? And it gives you, at the end of the day, a way to address a complex issue. Because imagine we have different experts, different disciplines that get involved. In all the different sectors, they tell you in a simple manner how to assess, what to look for in order to be able to express an opinion, not only of your current situation, but also what is the potential, because it has the higher level. It has what you can do next, because like the energy performance certificate, let's not talk about its value or not, whatever. That was the idea, not to just get an energy class score, but also leave some recommendations. So the whole approach, keep an eye for this. It's maybe not this year, but in the coming couple of years, it's going to be your new routine, your new reality.
Thank you. Does anybody have any questions?
There's one more there.
Kostas, Mr. Theophylactos.
Thank you. Costa, in your opinion, do you believe that the current instruments that we have for energy efficiency in buildings are suitable in order to move to the next level for the Greek fleet of buildings?
Right. So that's a tricky question, because I tell you what, I believe let's do what we have now, and if we can implement that, we're going to be at a much, much better state. Can we do better? Of course we can do better. We have, as I said, the standard and the solutions to become net positive. Net positive. But where's all this going to come from? That's, for me, the big challenge. Do you feel that I don't know the problems at my home, at your office? You don't know what it takes? Well, I don't have the funding. I've done certain things up to a point. I could have done a net positive tomorrow if somebody could finance it. If there's a volunteer in the audience, let's talk.
Anybody else?
Great,
Okay,
thank
you, Dr. Valas. I'm calling through has a presentation via online. Dr. Alexandros Papaspiridis, Managing Director of Nefos Consulting.
Thank you, Mr. Dosios. I would like to thank ENA and Mr. Stambolis for the invitation. I'm sorry I cannot be with you today. I'm based here in United Arab Emirates. And I would like to talk to you today about the revolution that is happening on AI and what does it mean for the energy sector. So first I would like to start saying a few words about the company that I work for, Nefos Consulting. It's a specialized AI advisory firm, which is differentiation is about how we are making AI real, fast for every type of organization. And we align it to the AI strategy. And the way we are doing this is, since we have developed, from our experience, we have developed a lot of initiatives and methodologies which allows to align this AI to your business goals. Because AI doesn't exist in a vacuum. It's not just a technology, but it's a technology that allows to accelerate your strategy. And also a key differentiation is about how quickly we have to do it, because this is not, the traditional IT projects that have been taking digital transformation projects that have been taking years to be implemented. By the time they were implemented, they were also obsolete. But AI is all about agility and about delivering results fast. So quick set the context about how important is what is happening, because you might hear that this is not, it's a fad, it's not for real. But really what we have in front of us is something really of historic proportions. Think about someone who has been going through the steam engine transformation and the industrial revolution. At this point, when these changes in technology is happening, it was not possible for someone to envisage that what would be the impact to the economies, to our lives, to the society. It's the same thing with AI. We are right at the beginning of this transformation, and it's very important that we understand that this now, given our experiences that we have with such transformative technologies, with the steam engine, with electricity, with the internet, with the personal computer, with the ubiquitous mobile telephony, is now we have something that will change entirely the way we work and the way that we operate as citizens. So this is now a big thing for us, is look ahead and really try to put this everything in historic context. And AI now represents one of these transformational technologies that is happening really once in a century. So let's look a little bit about, what is the impact of this technology with respect to energy. So what we have seen right now is that the global data center electricity usage is now a big driver of the additional energy demands in globally. So today, the increase that we have due in data centers globally is equivalent to the entire electricity consumption of Japan, a country, a G7 country, a country of 100 million. This is how much energy we are taking. And we are right at the beginning of this cycle. So this is already happening, and it's growing very, very quickly. And in Europe, what we see now that the energy demand is projected to triple by 2030. And, these are the big thing. When we look at the US, in US, the incremental energy demands is going to be coming a lot, will originate from what the data center needs are. So when we are designing for any country, when they are designing their energy plans, they have to consider that this is a big driver of the incremental growth that we see. It's not anymore how quickly the economy grows, but it's also the AI per se. So this is creating a virtuous circle, if you can think, because energy powers AI, AI powers the transformation of the economy, it accelerates the economy, which is creating additional needs. And in trying to put it a little bit in perspective of what it is and why this is driving. If we look only a few years ago, what we needed on an AI cluster, on a data center, or a series of data centers that were powering an AI cluster, these were requiring 10 megawatts. Just now, the top state-of-the-art clusters like the XA1, the Colossus one, it requires 10 times as much. It requires about 150 to 250 megawatts. And already there have been, and this is equivalent to powering the Thessaloniki. And, if we look about now the AI factories that have been announced, like the OpenAI Stargate, this is requiring 2 gigawatts. And this is the equivalent of the whole energy needs of Slovenia. And this is just one company. And this is the clusters that are required to not only to train its models, but also to run the inferencing and serve the customer base. And, you might say, okay, why? What is the need for, and why do these things grow so quickly? So when we're looking about how much energy was required to train the GPT-4, which is the current class, it's a year old large language model, this required about 50 to 20 megawatts of power, which is equivalent about the needs of the city of Chania in Crete. And if we see now, we go granular and we see one of the GPUs that NVIDIA is making, the H100, this GPU requires alone 700 watts. Now, if you multiply this by the millions of these units which are deployed globally, then you understand how we are now requiring such huge amounts of energy at a worldwide scale. And looking ahead now, again, looking at the granular level, what happens inside the data center, we talked about the one GPU, but if we look about the rack, which is, these boxes that you see, hundreds and thousands of them within a data center, Google is projecting that this would require about 0.5 megawatt of power before 2030. And they have already proposed a system in which they can start running 1 megawatt of power on a single rack. If you can imagine the power densities and the needs that this creates, because you have seen the volume of these data centers, you can understand how huge are the demands for energy. And eventually, the other key driver is what is the real demand for these services, AI services. And already ChatGPT, OpenAI has announced it has 400 million weekly active users. This is 400 million globally are using the services, and some of these users, like me, are using it many times a day. So you can imagine what is this need from just one company. And it's not just energy. As I presented last month at the annual sustainability conference of Athens College, these are also the demands on water. So just a 10 megawatt data center, which we already saw that this is not really big by today's standards, requires some 250,000 cubic meters of water annually, which is equivalent to serving 14,000 people. So you can understand the magnitude of the challenges that we are facing. But, these are the challenges. It's also an opportunity. Because, as I said, AI is not an energy consumer, but it's an energy consumer because it's a catalyst for transformation, of the economy transformation. So if we look about what are the good things that has happened because of this AI revolution, is that the big hyperscalers, these cloud providers, the big cloud providers like Microsoft and Amazon and Google, are focusing, because of their zero carbon pledges, they are focusing to procure huge amounts of renewable. Amazon and Microsoft have already announced that they are procuring more than 20 gigawatts of renewables globally. So this is a big driver of this energy demand, of the renewables energy demand. But another way that they're looking to provide this is not only through wind and solar, but also through nuclear. So Microsoft has announced that it will start powering up the third nuclear reactor of the 3 Mile Island, as well as the investments on small modular reactors that both Amazon and both Microsoft and Google have announced. So SMR is a big driver of how we do that. And the big difference, as you can understand, is these data centers require 24/7 power. They don't require only during the day when solar provides this energy. We want to have sustainable energy demands around the clock. Again, another element of innovation comes about how Microsoft has been working with the city of Helsinki to reuse the energy that is generated, which would be just residual waste heat, to warm the city of Helsinki. Obviously, this is not possible in the context of warmer countries like Greece, but this is a typical example about the innovation that we see with on AI data centers. Again, another key element of this innovation is how these long-term PPAs are allowing us to drive, because these are long-term. The data center is not there just for a couple of years, but it's there for a long time. That these long-term PPAs allow us the companies to invest and finance clean energy. Now, we looked at Network Consulting. We looked about what are the key applications, what are the key use cases of AI. And we did a thorough analysis, and we came to a grid of, which is quite complex, and I'm not going to go through it today step by step. It's an eye chart, with a lot of information. But you can only focus, if you have to focus somewhere, just focus on the top left on the dark green, which is the use cases which we classified that they have high business impact with lower complexity. Because when we look at the AI, it's also balancing these needs about how complex and difficult is the problem and what's the business impact. So if you look at this, we have a whole range of scenarios from grid balancing to shipping electrification. So just to give you a few examples of the scenarios that we are seeing is that AI can forecast faults, it can predict outages, optimize low voltage network loads, or it can improve the solar and wind forecast, really model best curtailment risks and trading dispatch. Or it can look at predicting equipment failure, monitoring emissions, and boost energy efficiency. So there's a lot of examples, and we are making available with ENA a white paper to talk about the different use cases of the application of AI. Because these are already happening. These are not hypothetical scenarios. These are scenarios that are already happening. So again, a few examples to make it very tangible, which are part of the white paper, is the use cases that Ørsted has used AI to increase the wind farm. So all these use cases have tangible business impact of the national grid in the UK, which are saving 300 million dollars annually. E.ON, another example on predictive maintenance, already reducing grid downtime by 30%. Avista Utilities. So there's a lot of these examples which we have covered, and we are addressing in the white paper that we are releasing. But again, focusing on one, because it's important to understand, okay, we have limited time today, but, I would like us to focus a little bit. Okay,
we have 2 minutes,
really be
Dr.
real for us?
Pavlaskis, we have 2 minutes.
Yes. Okay, real for us. Then we have a predictive maintenance scenario, which already companies are realizing. And I will go, thank you, Mr. Toshi, for the reminder. I'll go very, very quickly on the benefits. 25% fewer failures, 89% prediction accuracy. So we are driving ROI 3 times or 5 times the ROI within 18 months. So these are not long-term projects. These are projects that can really drive benefits very, very quickly. Again, what does it mean for Greece? Now we are having about 14 additional data centers which are being planned in Greece according to different announcements. Of course, Greece is very attractive because of the substantial renewable energy that we have. But, there are challenges. If you want to operate them, you need to have competitive energy prices. We have also challenges on grid and storage for alternative energy sources. And the big question mark eventually is, what is the real demand? What is the total capacity that satisfies the needs of Greece in the next few years? But more important is now, what does it mean for each of you? And here it's a great opportunity for ENA to take the lead here and mobilize the sector, utilize opportunities with arising from Horizon Europe and coordinate pilots that can leverage AI. So we are talking about the rise of AI first enterprises, and this is what everywhere we see globally. We are talking about the AI first enterprise here that I work in UAE. UAE have prioritized AI. They have an AI ministry. So this is a huge opportunity for Greece to be a regional leader in AI-powered energy innovation. So what does it mean for organizations that act now is that they will be able to lead their sector. They will be able to improve drastically their productivity in a short time frame, as I've already shown you. And moreover, they can now reimagine what are the opportunities that are now have become possible with AI. So AI is not only about productivity, but about how we are able to change the business model which we have. With that, I would like to close and thank you for attention. We're trying to cover a very broad sector. Feel free to contact me to schedule AI capability maturity assessment or to request the AI in Energy white paper. Thank you for your attention. And if we have time, Mr. Tosis, I'm open to questions.
Before making my question, one suggestion, you can add the use of water for the solution of the water scarcity. So a good solution there and good technology is the use of water from wastewater treatment plants, and whether you can, let's say, combine those two infrastructure, the wastewater along with the unit capacity for AI. One question for me, do you know if there is a profile of the daily energy consumption for AI uses? And are there any products that can tackle let's say, the peak problems with the peak demand?
So if I understood well, what's the 24-hour cycle of the energy demands of a data center, of an AI data center? That's the first part of your question.
If you have a daily profile, if you do have peaks in a daily, day-to-day, 24/7 use, so the peak is during the afternoon, the peak is during the night?
Yeah.
If there are any products, technological one or innovative products that can tackle that big problems?
Yeah, all three hyperscalers are actually trying to manage the energy demands that they have and optimize them and really turn off the unused equipment. However, this is not possible to do that on a large scale. So I would say that this is it follows some peaks. It depends on the workloads that you are actually running. It's a different when you're running training workloads, or whether you are running inference workloads, or you're serving some other infrastructure. So it varies a lot according to the workloads that they have. However, if you think a typical 24-hour electricity cycle, there is a much less difference between peaks and troughs. There's some difference, but there's not such marked because you cannot really power everything on demand.
Thank you, Dr. Vavasperidis. Do we have any questions from the audience? Okay, thank you. Now I'm calling Mr. Paris Franziskakis from DESFA. The floor is yours.
Hello. So hello, it is a pleasure to be here with you today. My name is Paris Franziskakis. I serve as the technical manager of DESFA. Congratulations for the event. Today I will guide you through our journey and our actions in innovation. And I will detail how we shape the future of tomorrow, how we integrate cutting-edge technologies and our collaborations in DESFA. So with regards to the agenda, we will start with a snapshot of DESFA, our infrastructure and capabilities. Then I will present our forward-thinking projects, our innovation team, and what lies ahead in our innovation agenda. So our innovation primarily focuses in three pillars: the decarbonization, the collaboration with universities, and the engagement with the startup ecosystem, with the Greek startup ecosystem. So I will go briefly through the details of DESFA because I believe that you already know. So DESFA has been a cornerstone through our establishment in 2007 in Greece energy infrastructure. We own and operate the national natural gas system, including the LNG terminal in Revinthusa, and we have undergone significant transformation, concluding in full ownership and bundling after our privatization in 2018. So we are committed to a safe, reliable and economically efficient operation, offering both regulated and non-regulated services to clients all over the world. So the infrastructure is detailed in this map. It is extensive and state-of-the-art, so we operate approximately 1,466 kilometers of high-pressure pipeline, including the LNG terminal of Revithoussa, metering regulating stations, operation and maintenance centers, dispatching centers, and also we're not just maintaining the network, but we are preparing also for the integration of new gases. And speaking of new gases, I would like first to mention a prime example of our innovation strategy, which is the dedicated hydrogen pipeline. It is a 1 billion project, now technically approved under the European Commission PCI list. It is a 540 kilometers pipeline which will transport pure hydrogen from southern Greece to Central Europe, forming a part of Corridor E of the European hydrogen backbone. So with this way, we are building a bridge between high solar and wind potential in the south and future demand hubs in Central Europe. Alongside hydrogen, we are advancing decarbonization also through the Apollo CO2 project, which is Greece's first CCS carbon capture hub. This project includes a dedicated CO2 pipeline connecting emitters in Attica region with the liquefaction terminal at Revithoussa terminal, and ultimately storage in the Prinos offload offshore field. So the Apollo CO2 is a bold step in line with EU's industrial carbon management strategy and places Greece at the forefront of future European CCS network. So apart from the integration of new gases, DESFA has many actions concerning innovation and collaborations with numerous universities and research centers. So I would like to mention some of our innovative efforts, which include AI-based gas forecasting applications, smart inspection with satellite motion mapping, and smart contracts, as well as hydrogen injection simulation for our network. So we work closely with universities and research centers in all cases to ensure that these ideas translate into practical and scalable solutions for all business functions. So innovation is not a side project for DESFA. We do not consider it a side project. We want to consider it as a culture to be embedded in our daily routine. So, and in this direction, in the past years, we have created our innovation lab. Our innovation lab, it is a team, a cross-functional team of engineers and professionals. So through the innovation lab, we have established an accelerator. The accelerator is up and going. This accelerator has a dedicated portal which we can use to launch call for ideas. We have recently launched our first call of ideas, and we now are in the development and the conclusion of proof of concepts. So these proof of concepts are dedicated to DESFA needs, and with this we collaborate very closely with the selected startups according to our business functions. So in the next slide, we have some examples of our recent concluded proof of concept. So the first one on the left side includes a proof of concept of a recent developed AI platform for technical document analysis and contract management optimization. So these two POCs have shown real promise, demonstrating significant potential for AI document management, and also an upcoming POC on the right side concerns the further exploration for the integration of AI and sensor technology in safety and workplace analytics. I would like also to mention now that in the next week we are launching our second call of ideas in the 12th of May. The topics are included on the bottom of the slide. They include environmental management application, gas grid evolution, digital well-being and onboarding. So finally, I would like also to close the presentation mentioning our technical training and R&D center, which is a facility located in Thessaloniki, and you can visit it. It is the first of its kind in the Balkans, serving as a hub for green gas, education and skilling. Our mission is clear, to prepare the workforce for the transition to a green gas economy, ensuring knowledge and capability involvement alongside technology. So this is all from my side. Thank you very much. I appreciate the invitation to the event, and I welcome any questions. Thank you.
Thank you, Mr. Franziskakis. You were very efficient and you're on time above all of us. One question. From all those technologies and products that you are searching for, is there anything that you are already using on a day-to-day operation?
With regards to the POCs and our collaboration with startups, the AI implementation in document management and contract management, it is a tool that for sure will be for use in DESFA. We have, for example, a huge technical archive of documents, drawings, process diagrams. So it would be very efficient to gain time and resources in extracting the necessary data for the operator that it is on field and tries to find, for example, the manual of a specific equipment. So this is ongoing, and for sure it will be applicable in the near future.
Do you have any questions from the audience for Mr. Franziskakis? No? Thank you.
Thank you.
Now I'm calling Dr. Koukouzas. Doctor.
Yes, hello everybody. I would like first of all to thank ANA for supporting this conference, and especially Mr. Stabolis. So I would like to present today, let me check. Okay. I have to discuss about the hydrogen technology. So, as we discussed before about CCUS in the past events of ENA, today we would like to discuss about hydrogen, which is quite interesting as an application for and quite innovative for energy. So why we do that for hydrogen? Because hydrogen is ready for vehicles, fuel for vehicles, for ammonia production, for fertilizers, and for metal refining. How can be produced? Can be produced by renewable energy. So this is a clean fuel, and is especially a key role that hydrogen can play for the transition, for energy transition. As we all here know about hydrogen, we have the hydrogen production, hydrogen transportation, hydrogen storage, and hydrogen distribution and utilization. So hydrogen is not a byproduct of a production process, as it is CO2, but is produced at a later stage. So hydrogen transportation is also important, but we need to comply with strict protocols to ensure safety. Hydrogen storage, this is something that we discuss probably a little bit more today. This is something important for the period when we need hydrogen for high demand periods. And finally, hydrogen distribution and utilization. So we need the end users deploy hydrogen to satisfy demands mainly related to transport and energy production. We have hydrogen production with different colors. So we know all of us the black hydrogen, gray hydrogen, blue hydrogen, green hydrogen, turquoise, purple or pink, and white. The last one, white hydrogen, is, we call it also geological hydrogen or natural hydrogen. So this is a lot of discussion, but we cannot do it today about this. So this is what they found in the Earth. But all the rest comes from different methods like steam methane reforming, electrolysis, or biomass gasification. So especially the European Commission is mainly focused on green hydrogen as it comes from electrolysis using renewable energy sources. So we have the different process of hydrogen production, and this is the green hydrogen. So this comes from water, electrolysis, as we said before, and we have different methods developed as the alkaline water electrolysis, the polymer electrolyte membrane, or the solid oxide electrolyzer cell. How we transport all this hydrogen during the low energy demand or the high energy demand. During the low energy demand, the hydrogen requires transportation from the production facility to the underground or above ground storage sites. During the high energy demand, the stored hydrogen should be transported from the storage tank to the end users through pipelines, railway, road network, or maritime transport. So what we have as let's say alternative is the gas blending. So we can transport it with the natural gas. So this is an advantage that we can use the current network, and we can use 10% of this gas for hydrogen transportation. These are the other two preferred methods. This is the road network and maritime transport. And let's go now to hydrogen storage. A part of the above ground hydrogen storage, which means the storage tanks, we have the underground hydrogen storage. That means geological formations. Which geological formations? Saline aquifers or porous media, the abandoned rock mines, that means salt mines or limestone or coal mines, depleted hydrocarbon reservoirs, and salt formations like salt cavern. Another technology is the lined or unlined hard rock caverns. I would like to emphasize to this storage as it is quite innovative, and this is something that is discussed within the European Union now, and this is something that we have new calls in research to finance research projects in these fields. So for abandoned rock mines where we put hydrogen, there is no need for drilling as there are existing caves. Of course, there is a possible availability of facilities and machineries. When we go to saline aquifers, porous media, there is a strong experience from decades, but they require porous formation and impermeable formation to prevent migration. It's something like that we discuss also on CO2 storage. Here, this is a schematic representation of hydrogen storage in porous rock. So you can see the impermeable cap rock forming an anticline that acts as a trap, and the underlying porous reservoir rock as presented in the figure. So what is the main uncertainties for this hydrogen storage in porous media or saline aquifers? First of all is the cap rock. We need to be sure about the cap rock, that there is no any fracture, that there is no any diffusion. Second is the hydrogen plants. Third is the injection production. So we need to keep the pressure, temperature change, the strains changes. Fourth is the Cassion gas. So we need to be sure about the gas missing for the Cassion gas. The Cassion gas brine and structural geology. That means faults, stress, activations, different activations, overpressure, and other things. When we go to salt caverns, there is a large capacity for salt caverns, and there is a high rate of hydrogen storage and extraction. That means that it gives a flexibility to supply energy to the grid when required. Actually, in other words, salt caverns, it's a technically preparation of the storage site. So that means that we give the depth of this formation of the salt cavern. We give the diameter, and so that means that we need to do all the cycling of hydrogen and give us flexibility, so we can put hydrogen to the grid when it's necessary. So when we go to hydrogen in depleted oil and gas fields, we have optimum conditions for gas storage in these fields. We have years of experience. We have existing facilities and availability of a residual gas quantity. This is the Cassion gas in our case. So this is how it looks, the salt cavern. So you can see on the right hand how this salt cavern is shown. So this is the main principles is to utilize the natural pressure in the salt caverns, large storage volumes, and cylindrical shape. So to construct a storage salt cavern, we need to achieve a leaching process, to use the fresh salinity, low salinity water. When we complete this leaching, the gas is injected and replace the salt saturated brine. Here are some technical characteristics of the salt caverns. So you can see the geological formations are salt formations. We need a structure of salt domes or bedded salt. A composition of this is 95% alite. The cap rock is anhydrite gypsum limestone, a depth of 200 up to 2,000 meters. Normally 300 meters is enough. The maximum salt temperature around 8 degrees and the volume. So this is the lined or alnite hard rock caverns. So here we excavate a solid formation, like a hard rock formation. We reinforced with a specialized lining system, and we make like, in other words, like a concrete formation in hard rocks ready to put hydrogen inside. So we need to avoid tectonic zones, seismicity regions, karst systems, and high permeability rocks and sedimentary rocks. Here is a picture of how it looks, this lined or unlined hard rock cavern. So as a synopsis for hydrogen production, we have all the different colors of hydrogen production, coming from coal, gas, from green energy, from even from fossil fuel pyrolysis, turquoise. We have the different transmission, distribution, road pipeline and other things, and hydrogen storage, as we said before, depleted hydrocarbon fields, salt formations, saline aquifers, abandoned rock mines. So how can hydrogen value chain be applied in Greece? We have hydrogen transportation network. We have available geological storage sites, and we need also to see the prospects for combined use of hydrogen and CCUS technologies. Here are the pipelines, as I think some previous speakers showed before, the pipelines in Europe. This is the pipeline network for 2030 and 2040. This is the pipeline network in Greece. The different possibilities for hydrogen transportation through the Greek ports. And here are some places in Greece where we have some suspicions, let's say, about the possibility to hydrogen storage in Corfu, Etelokarnania, Kefalonia, or Kavala. These are mainly the places where we have all these salt domes, as we discussed before. But this is a very premature technology for the time being, so we need to put a lot of emphasis in research on this. So another thing is the synergy of CCUS and hydrogen.
We have 2 minutes.
Yes, okay, I go very fast. So this gonna be the hydrogen storage with CCUS, where hydrogen can use CO2 as a cation gas. Here we have the hydrogen applications in Europe. In Europe, the current trends, so a lot of interest from companies nowadays to store hydrogen. Here are some projects. We participate in the first one for the geological storage of hydrogen in Europe, but also there are some others, as you can see, also for the production, not only the storage. So what is the gaps and requirements in Greece? We need to see the hydrogen production together with the health and safety and CO2 transportation, but also we need to enhance our knowledge and expertise in hydrogen, universities, industrial sector, students, and funding opportunities for all this hydrogen storage and production. Thank you very much.
Thank you, Dr. Koukouzas. One question from my side. What do you believe that will be the next big thing, innovative product process in the hydrogen value chain?
As we are now discussing about production of hydrogen in different parts of Greece, this is going to be in the next 5 to 10 years, more or less. But for the hydrogen storage, this is going to be another 5 years, more or less.
10 years, 5 to 10 years. Okay, thank you. Any questions from our audience? No. Thank you, Dr. Koukouzas. Last but not least, Dr. Patsoules from IENE.
Thank you. Γεια σας. Παρά το ότι μου ζητήθηκε να ετοιμάσω την παρουσίαση αυτή στα αγγλικά, την ετοίμασα, αλλά επειδή τα 3 θέματα που θα αναπτύξω αφορούν το ενεργειακό θέμα της Ελλάδας, θα τα πω ελληνικά για να τα καταλάβετε και καλύτερα. Να πάμε στο πρώτο slide. Πού σημαδεύω ρε παιδιά. Πάμε από εδώ. Ωραία. Τα 3 θέματα λοιπόν που θα σας αναπτύξω όσο γίνεται πιο γρήγορα αφορούν την εκμετάλλευση πόσιμου νερού από πηγές υποθαλάσσιες στον ελληνικό χώρο. Το δεύτερο, γεωθερμική ενέργεια από ταμιευτήρες υψηλής ενθαλπίας για παραγωγή ηλεκτρισμού, ψήξης και θέρμανσης. Και το τρίτο, παραγωγή πράσινων electrofuels. Πάλι δεν κατάλαβα. Δεν κατάλαβα τι μου έδειξες. Πατάω 4 διαφορετικά κουμπιά και δεν γίνεται τίποτα. Μήπως εξαντλήθηκαν. Και βιαζόμαστε υποτίθεται. Very complicated machine, you see. Λοιπόν, θα με βοηθήσεις? Από εδώ. Λοιπόν, τι έχουμε, πήγαμε πίσω. Όπα, πολύ πίσω, γιατί? Για τα λόγω. Πρέπει να ρυθμίσω αυτό το πράγμα, δεν γίνεται. Έχει φύγει εντελώς, δεν είναι η σειρά των slides που είχα. Δεν ξέρω τι.
Μιλήστε και το χειριστούμε από πάνω τεχνική.
Να το χειρίζονται τεχνική. Πολύ ωραία. Θα τους λέω next και next. Ωραία. Πάμε στο πρώτο λοιπόν. Μάλιστα εδώ υπάρχει και μια προηγούμενη. Μια προηγούμενη από αυτήν που βλέπουμε μια πηγή μέσα στη θάλασσα. Αρχίζουμε από εδώ. Πάμε στο επόμενο. Τέλος πάντων, είχα μια φωτογραφία μέσα στη θάλασσα όπου βγαίνει η πηγή του υποθαλασσίου νερού. Εδώ εξηγώ τη γεωλογία πώς βγαίνει αυτό το νερό μέσα από τον πυθμένα της θάλασσας. Εδώ είναι ο πυθμένας της θάλασσας και με διάβρωση του υπεδάφους και την τροφοδοσία από υδροφόρους ορίζοντες έρχεται το νερό απάνω. Πάμε στο επόμενο. Επόμενο. Μάλλον κουραστήκαμε.
Θα πηγαίνετε με αυτά εδώ.
Ναι, για να δω.
Αυτά εδώ, πριν μπρος και πίσω, έτσι.
Για να δω. Πατάμε το πάνω κάτω.
Ναι, με το πάνω. Με το κάτω θα πηγαίνετε μπροστά, εντάξει.
Ωραία. Ωραία. Εδώ λοιπόν βλέπετε αυτή την πηγή, την υποθαλάσσια που εκδηλώνεται κατά αυτόν τον τρόπο που βλέπετε εδώ. Όταν την πρώτο είδα, ευχαριστώ. Πήραμε μια βάρκα, υποψιαζόμουν να τη συνέβαινε και με ένα κατσαρολάκι πήραμε νερό από εκεί και ήπιαμε και ήταν μια χαρά νερό. Δίπλα ακριβώς βλέπετε φωτογραφία από το εσωτερικό της θάλασσας, τη κολόνας του upstream water flow. Σας πάω στα φράγματα της ΔΕΙΟ που έχουμε downstream water flow για την παραγωγή ηλεκτρισμού. Εδώ έχουμε upstream water flow που επίσης μπορεί να κινήσει μια αντλία, να παράξει ρεύμα κλπ. Αλλά πέρα από το ρεύμα έχουμε και πόσιμο νερό. Σε αυτή την περίπτωση θα πρέπει οπωσδήποτε να βάλουμε εξέδρα πετρελαίου. Προσέξτε, όλα αυτά τα χρόνια που ήμουν στα πετρέλαια κάναμε διαγωνισμούς, φέραμε εταιρείες για να ψάξουν για πετρέλαιο και το μεγάλο πρόβλημα που είχαμε ήταν οι αντιδράσεις των κατοίκων. Χωρίς λόγο. Δεν θέλω να επεκταθώ ποιοι ήταν οι λόγοι, αλλά ήρθαν εταιρείες, πλήρωσαν, αγόρασαν τα δεδομένα και όλοι λέγανε όχι, εξέδρες, δεν θέλουμε εξέδρες. Οι εξέδρες είναι απλωμένες παντού σε όλο τον κόσμο. Πάνω από 80.000 γεωτρύπα να παράγουν πετρέλαιο σε όλο τον κόσμο. Και εδώ, επειδή δεν παίρναμε εργάτες από την περιοχή, δεν κάναμε δώρα κλπ. Έδιωχναν τις εταιρείες. Και έτσι έχει καθυστερήσει πάρα πολύ αυτή η ιστορία με το πετρέλαιο. Έτσι λοιπόν, Το πήρα πατριωτικά και θα σας δείξω 3 εξέδρες που είναι καταπράσινες, για να μπορέσει ο Έλληνας να καταλάβει ότι έχει ανάγκη στις εξέδρες από τη μια, και όταν μπει και στη μελέτη των εξεδρών πετρελαίου θα καταλάβει ότι, θα σας εξηγήσω αργότερα, ότι είναι εντελώς ασφαλής για διάφορους λόγους που θα πούμε στη συνέχεια. Από αυτό το project λοιπόν, που μπορεί να εφαρμοστεί κάπου στο ναύλιο είναι αυτό, αλλά υπάρχουν και άλλες 30 πηγές σε όλη την Ελλάδα με τεράστιες παροχές, από ό,τι το ψάξα, μπορείτε να δείτε ότι όταν το flow rate είναι 15 περίπου κυβικά μέτρα το λεπτό, το δευτερόλεπτο, μπορούμε να πάρουμε το χρόνο 373 τόνους πόσιμου νερού. Είναι αρκετά μεγάλες ποσότητες.
Πρώτο είναι η υδροδότηση της Αθήνας. Τόσο νερό καταναλώνουμε στην Αθήνα.
Ναι, ακριβώς. Γιατί είναι μεγάλες πηγές και το νερό πάει χαμένο μες στη θάλασσα. Αυτό το άρθρο το ανακοινώσαμε με τον συνάδελφο τον Καρλατήρα στο World Oil, που είναι ένα από το σοβαρότερο περιοδικό στη βιομηχανία του πετρελαίου, και έλαβα πάρα πολλά emails όπου ουσιαστικά διεπίστωσα ότι αυτή η τεχνολογία δεν έχει εφαρμοστεί πουθενά στον κόσμο. Άρα να μια ευκαιρία, να ένα innovative energy να αναπτύξουμε στην Ελλάδα. Δεν θέλει και πολλά λεφτά. Πάμε στο δεύτερο. Πώς θα αναπτύξουμε την παραγωγή ηλεκτρισμού ψήξης θέρμανσης από γεωθερμικούς ταμιευτήρες υψηλής ενθαλπίας. Εδώ ας τα διαβάσουμε στα αγγλικά για να μην τα μεταφράζω ελληνικά. What does this innovative technology actually offer? Great investment opportunities. It uses innovative technologies, clean energy production, high efficiency energy production, high availability power production unit, huge reserves in Greece, huge, really huge. Zero environmental impact, high capabilities options for cogeneration covering different types of needs for the societies. It's very advantageous for the islands to produce hot water, heating, cooling, water desalination, district heating, domestic and or other processes support of grid stability, electric vehicles, fast charging, etc. Εδώ που έχουμε εντοπίσει, όχι μόνο εμείς, ο κόσμος όλος, για παραγωγή γεωθερμίας υψηλής ενθαλπίας, είναι το ηφαιστειακό τόξο του Αιγαίου, το οποίο με καρδιά τη Σαντορίνη, που όλοι ξέρετε ότι είναι ένα ηφαίστειο ενεργό, αυτό είναι η Σαντορίνη, κάναμε κάποιες μελέτες και είδαμε ότι μπορούμε, και εδώ είναι η καλντέρα της Νησίρου. Εδώ είχα την ευκαιρία το 1982, σαν τότε νέος γεωλόγος μηχανικός ταμιευτήρων, να παρακολουθήσω την γεώτρηση που έγινε εκεί, και προσέξτε τα νούμερα. Βρήκαμε στα 1700 μέτρα 350 βαθμούς Κελσίου. Δεν υπάρχει. Θυμηθείτε το αυτό. 350 βαθμούς Κελσίου στα 1700 μέτρα. Όταν λοιπόν έχουμε κάποια φαινόμενα που συμβαίνουν στο υπέδαφος, συνήθως πάντα στη βιομηχανία του πετρελαίου προστρέχουμε σε σεισμικές διαγραφίες για να δούμε πώς είναι δομημένο το υπέδαφος. Τώρα, επειδή και η γεωθερμία, τα γεωθερμικά ρευστά και τα πετρελαϊκά ρευστά χαρακτηρίζονται από υψηλές πιέσεις και υψηλές θερμοκρασίες, high pressure, high temperature, χρησιμοποιούν και τις ίδιες τεχνολογίες. Απαιτούνται οι ίδιες ακριβώς τεχνολογίες που χρησιμοποιούνται ήδη στα πετρέλαια και έχουν πειραματιστεί ανά τον κόσμο και δοκιμαστεί, και ήδη έχουν αρχίσει να δοκιμάζονται στη γεωθερμία. Εδώ λοιπόν βλέπει κανείς ένα σωρό από διαφορετικούς σχηματισμούς και έχει πολύ μεγάλη σημασία να ερμηνεύσεις τι σχηματισμοί είναι αυτοί, ώστε να αναπτύξεις τη στρατηγική παραγωγής ενέργειας, αποθήκευσης. Μιλάμε όλοι για μπαταρίες και ίσως δεν έχουμε καταλάβει ότι η μεγαλύτερη μπαταρία και η πιο σοβαρή είναι η γη. Τα ηφαίστεια, περιττώ να σας πω ότι λειτουργούν στη γη εδώ και 4,6 δισεκατομμύρια χρόνια. και θα λειτουργούν για άλλα τόσα. Επομένως, μπορούμε να πάρουμε όση ενέργεια θέλουμε με καθαρό τρόπο για να την εκμεταλλευτούμε. Προσέξτε, τώρα πάμε επί του πρακτέου. Στον Καναδά, αυτό το μπλοκ που βλέπετε έχει 2 γεωτρήσεις, η κάθε μία 8.500 μέτρα βάθος, 8.500. Αυτές με οριζόντιες γεωτρήσεις συνδέονται στα 8.500 μέτρα και έτσι αποκαθίσταται το loop που θέλουμε να περιστρέφονται τα υγρά, γιατί επειδή έχουμε διαφορετική πίεση και διαφορετική θερμοκρασία due to differential pressure and temperature, we have fluid flow. Όταν λοιπόν έρχεται το ρευστό επάνω, εδώ με μηχανισμούς διάφορους, θα δούμε μετά, μπορούμε να κλέβουμε στην κυριολεξία τη θερμότητα που κουβαλάει, να την κάνουμε ηλεκτρισμό ψήξη θέρμανσης, στη συνέχεια το ρευστό φεύγει, ξαναζεσταίνεται και ούτω καθεξής. Εδώ είναι το εργοτάξιο τέλος πάντων. Θυμηθείτε τα 8.500 μέτρα και τους 210 βαθμούς. Εμείς τα 1.700 βρήκαμε 350 βαθμούς. Αυτό είναι δυναμικό, πολύ σπουδαίο για εκμετάλλευση. Τώρα, επειδή διεύθυνα μια ομάδα για να φέρουμε αυτή την τεχνολογία στην Ελλάδα και τη φέραμε κάπως, δεν θα επεκταθώ εκεί, όμως το πρώτο ερώτημα που έβαλα στην ομάδα ήταν ότι αν έχουμε ένα μπλοκ τόσο μεγάλο σαν το προηγούμενο που εφαρμόστηκε στον Καναδά, να εφαρμόσουμε σε νησάκια ελληνικά, δεν θα το κάναμε ποτέ, διότι δεν μπορείς να καλύψεις όλη την περιοχή, και έτσι καταλήξαμε σε αυτή την εντελώς πρωτότυπη μορφή ανάπτυξης και εκμετάλλευσης των ταμιευτήρων γεωθερμίας, όπου με ένα σύστημα monoaxial drilling, με ένα μονοαξονικό, το οποίο μάλιστα έχει και τα εξής περίεργα, είναι πτυχωμένη η σωλήνα για να μπορεί να απορροφά όσο γίνεται περισσότερη θερμότητα από το σχηματισμό. Πάμε στους 350 που ακούσατε προηγουμένως και εδώ η μπλε στήλη δείχνει νερό που εισπιέζουμε μέσα. Το νερό ζεσταίνεται, υπερθερμαίνεται στους 350 βαθμούς και επειδή το σύστημα ελέγχεται και είναι καπακωμένο από πάνω, θα σας πω πώς, δεν μπορεί να βράσει, αλλά αναπτύσσει τεράστιες πιέσεις. Αυτές οι τεράστιες πιέσεις, το μπλε νερό που έχει πάρει την υψηλή πίεση ανεβαίνει από τον κόκκινο σωλήνα και όταν φτάνει στην ατμόσφαιρα με διαβατική μεταβολή γίνεται ατμός, αλλά είναι ατμός από 350 βαθμούς, έχει ισχυρή δύναμη και μπορεί να διοχετευτεί σε steam generators για παραγωγή πάρα πολλής ενέργειας, ηλεκτρισμού και παράλληλα και ψήξης θέρμανσης. Προσέξτε τώρα, αν δείτε εδώ που βγαίνει ο ατμός, μετά την παραγωγή ηλεκτρισμού ψήξης θέρμανσης, εισάγεται σε ένα κλειστό σύστημα, ο οποίος ατμός επαναυγροποιείται και ξαναμπαίνει στο σύστημα εδώ. Σαν μπλε νερό πια, που υγροποιείται, και έχουμε αυτή τη λούπα πια σε ένα άξονα που μπορεί σε λιγότερο από στρέμμα να έχει αυτή την τεχνολογία. Είναι πολύ έξυπνη, τη δοκιμάσαμε, λειτουργεί πραγματικά και επειδή και πάλι εδώ οι πιέσεις είναι τεράστιες, δανειζόμαστε από την βιομηχανία του πετρελαίου αυτό το σύστημα που είναι γνωστό σαν blowout preventer. Είναι ένα πολύπλοκο σύστημα. Βάλε καλά λίγα γιατί είχαμε καθυστερήσει εδώ. Λοιπόν, θα σου κάνω extensional drilling. Ξέρεις τι σημαίνει αυτό. Λοιπόν, τέλος πάντων αυτή η συσκευή εδώ, όταν μπαίνει εδώ, προστατεύει το σύμπαν από πιθανές πιέσεις, εκρήξεις κλπ. Ένα πείραμα για 25 ΜΒ ενέργεια και availability 90% με CAPEX 59 million euros, IRR 19% και net present value 65,3 million euros, έχει payback period 5 years. Και τώρα πάμε στο τρίτο. Το τρίτο λοιπόν έχει να κάνει με utilizing the high pressure, high temperature CO2 from the sea bottom chimneys in order to react in a special chemical process with the hydrogen to produce electrofuels. Αυτά που μας έλεγε ο κύριος Κούκος προηγουμένως, να αποθηκεύουμε το διοξείδιο του άνθρακα, εδώ θέλουμε να το βγάλουμε έξω. Προσέξτε πώς. Υπάρχουν καμινάδες υπεδαφικές, από τις οποίες εκλείονται διάφορα υγρά και αέρια. Μεταξύ αυτών, μία που εντοπίστηκε τα τελευταία χρόνια είναι μια καμινάδα διοξιδίου του άνθρακα στην περιοχή του Αιγαίου, η οποία σε βάθος μόνο 450 μέτρων, 450 μέτρα νερού, δεν έχεις να κάνεις γεώτρηση 8.500 μέτρα, στα 450 έχεις τους 210 που οι Καναδοί βρήκανε στα 8.500. Εδώ μιλάμε για τεράστια ποσά ενέργειας που μπορείς να τα πάρεις εύκολα και φθηνά. Μαζί με το διοξείδιο βγαίνουν κι άλλα. Ένας τρόπος είναι να τα αφήσεις όπως εδώ και χιλιάδες χρόνια εκλείεται το διοξείδιο του άνθρακα, αλλά και εδώ μελετήσαμε μια μέθοδο για παραγωγή electrofuels. Για να σας δώσω άλλο ένα παράδειγμα για τα chimneys που υπάρχουν, οι καμινάδες. Αυτό είναι από περιοχή του Κατάκολου, όσο ψάχναμε στο Κατάκολο για πετρέλαια κλπ. Υπήρχε μια περιοχή που αν έβαζες το χωνί και πολλά άλλα χωνιά και έβαζες ένα σπίρτο εκεί, άναβαν πολλές φλόγες, πάρα πολλές, 1.000 φλόγες θέλεις, 2.000 φλόγες, δηλαδή έχεις ενέργεια, αλλά παρόλα αυτά, παρά το ότι προτείναμε να το εκμεταλλευτούμε, δεν προχώρησε ποτέ το θέμα. Βέβαια, εδώ είναι πολύ καλύτερα να το καίγαμε και να είχαμε διοξείδιο του άνθρακα αντί για μεθάνιο, γιατί το μεθάνιο, όπως ξέρετε, είναι χειρότερο για το περιβάλλον. Εδώ είναι το διάγραμμα του πώς από το διοξείδιο του άνθρακα της στήλης που είδαμε προηγουμένως στο Αιγαίο, μπορούμε να, από το διοξείδιο του άνθρακα παίρνουμε ρεύμα καταρχήν, έχουμε παραγωγή ηλεκτρικής ενέργειας και με ηλεκτρόλυση παράγουμε και υδρογόνο. Και διαβάζω a typical overview of a project of this type includes creation and installation of an offshore platform, which πάλι πλατφόρμα και εδώ, which will be used exclusively for the production of green energy, green hydrocarbons. Drilling in an undersea area with CO2 stack, abduction of CO2, and creation of the first path to create distilled water by using the heat carried out by the CO2 chimney, 220 degrees Celsius, electrolysis of a distilled water to generate hydrogen by using the heat of CO2 for electricity production, creation of a second route for electricity production, channeling of CO2 and hydrogen for the production of electric fuels, creditable green fuels, based on the Fischer-Tropsch process in order to produce green hydrocarbon mixture. Τέλειωσα εδώ. Αυτή είναι το Ecofis, North Sea Ecofis Complex Εξέδρες. Το έβαλα γιατί εδώ ολοκλήρωσα το διδακτορικό μου και το μεταδιδακτορικό και είχα τη δυνατότητα να αποκτήσω φοβερές εμπειρίες, τις οποίες σήμερα θα μπορούσαμε να εφαρμόσουμε από τα πετρέλαια, να τις μεταγγίσουμε για την γεωθερμία στην Ελλάδα. Και έχω και αυτό να σας πω, for the safety of workers and the environment, as last but not least, to kindly inform you that I had the honor of representing Greece at the technical panel in Brussels, where we structured the directive 2013/30 EU, strictening the regulations in force until then and adding others in order to overprotect both the marine environment and workers on the oil rigs in quite harsh conditions. This directive was harmonized in the legislation of all the EU member states, and what has been observed over the years is the fact that these accidents have been reduced to a minimum with modern protection of the environment from oil spills. Είχαμε παραδείγματα διάφορα και ευτυχώς δούλεψε αυτή η διρεκτίβα. Τέλειωσε, ευχαριστώ για την προσοχή σας.
Thank you, Dr. Vassiliadis. We have one question from the audience.
You can start first.
Okay, one question from me. Is there an official mapping of the areas of, you call it the water, how we call it, meteoric water areas?
Yes,
Is there an official
it's a
map
meteoric water, yes.
of the areas where are those?
Sorry.
Is there an official map of the Greek, in the Greek territory regarding the areas with meteoric water?
Yes, but as you understand, it is confidential.
So it's not confidential. So Hellenic Petroleum, LP has it.
No.
Who?
You myself.
You yourself. Okay. Thank you.
Καλησπέρα. Κωνσταντίνος Δρούγος ονομάζομαι, βάσει Carbon Management. Για τις υψηλής ενθαλπίας τα πεδία είναι συνήθως σε νησιά που είναι συγκεκριμένα, είναι ας το πούμε απόμακρα, νήσερος, ας πούμε, πρέπει να κάνεις ολόκληρο σύστημα κλπ. Η τεχνολογία έχω ακούσει, δεν είναι εσείς ο ειδικός, προφανώς έχει, I can say it in English, the technology has been advancing and we can use low enthalpy fields. What does it mean? You know, what level are we now at the low end? Can we produce at 100 level for electricity production? I'm talking about right now, generation.
Η χαμηλής ενθαλπίας ήδη χρησιμοποιείται στην Ελλάδα, είναι για θερμοκήπια κλπ.
Yeah, but besides that, you know, we're talking generation.
Δεν μπορεί να παράξει ρεύμα η χαμηλή ενθαλπία. Συγγνώμη.
Is there new technologies on this field? That's the question, really.
Γιατί για το ρεύμα θέλεις πολλή ενέργεια και εκεί αυτή την ενέργεια την βρίσκεις στην υψηλή ενθαλπία. Προσέξτε. Το παράδειγμα του Καναδά που είδατε, μίλησα με τον CEO της εταιρείας που ανέπτυξε αυτό, όταν του είπα είμαι από Ελλάδα. Συγγνώμη. Όταν του είπα τηλεφωνώ από Ελλάδα, θέλουμε να αναπτύξουμε αυτά, μου λέει έρχομαι στην Σαντορίνη αν κάνετε 250 ευρώ την μεγαβατόρα. Έρχομαι, κατευθείαν, χωρίς να του πω τίποτα άλλο. Τέλος πάντων, του είπα ότι έχουμε και πιο έξυπνους μεθόδους από τις δικές σας, που ολόκληρο μπλοκ στα 8.500 μέτρα βρήκανε θερμοκρασία αυτή που βρήκαμε στο διοξείδιο του άνθρακα. Παρ' όλα αυτά, επειδή εκεί η μεγαβατόρα έχει κόστος 300 με 350 ευρώ, είναι βιώσιμο το project. Εδώ που την έχουμε χαμηλά, όμως και με χαμηλότερη τιμή μεγαβατόρας, αυτά τα projects είναι βιώσιμα. Γιατί είναι πολύ υψηλή η ενθαλπία της ενέργειας στους ταμιευτέρες αυτούς.
Για να καταλάβω, I saw in one of your graphs that it was like 59 million euros for 25 megawatts, correct? About 2.5 million, or give and take. So this is for high enthalpy?
Yes.
Okay. For low enthalpy, is higher capex? How does
For low enthalpy, you go to... Ναι, ναι.
Η γεωθερμία είναι τριώριδο. Η πρώτη είναι η χαμηλή ενθαλπία. Αυτή είναι για κτίρια, για θέρμανση και ψήξη. Και είναι από τις λίγες τεχνολογίες που μπορούν να κάνουν το κτίριο NZ. Γιατί δεν χρειάζεσαι ούτε ηλιακούς συλλέκτες, ούτε οδάιτε τίποτα. Λοιπόν, αυτό είναι το ένα. Υπάρχει το ενδιάμεσο, αυτό είναι μέχρι ό,τι η θερμοκρασία βρίσκεται στη γη. Υπάρχει μέχρι τους 90 βαθμούς, όπου είναι για θερμοκήπια, για σπα, είναι αυτά που έχουμε στο Κόζαρ, αυτά που έχουμε στην Ιπάτη και τα λοιπά, στα Μέθανα και τα λοιπά. Και πάνω από 90 είναι το υψηλής ενθαλπίας, το οποίο δεν υπάρχει παντού. Το πρώτο, το χαμηλής ενθαλπίας, είναι παντού. Εδώ να κάνω μια τρύπα και την άλλη να την κάνω λίγο πιο πέρα, μπορώ να, με τη γεωθερμική αντιλία θερμότητος να βγάλω θέρμανση και ψήξη. Τόσο απλά είναι. Αυτά που λέει ο κύριος Πατσουλεδόπτος Πατσουλέ είναι υψηλή ενθαλπία. Είναι, πάμε στην Ίσυρο, στη Σαντορίνη, στα Μέθανα, στη Μήλο.
Ή πολύ βαθιά. Μπορούμε να πάμε πολύ βαθιά. Αλλά κοστίζει πολύ.
Σε μεγάλο παιδί δεν βρίσκεις. Τη Μήλο την καταστρέψαμε. Ποιος ΔΕΗ. Τώρα τα λέμε 1970 κάτι.
Το πεδίο εκεί είναι στη Μήλο, δεν έφυγε.
Αυτή την ερώτηση δεν άκουσα, Κωστή. Η ΔΕΗ τι κάνει που έχει αυτό το αντικείμενο στα χέρια της τόσα χρόνια?
Δεν μπορεί
Τίποτα.
να κάνει τίποτα διότι έκανε το λάθος το 78.
Να το πάρει κάποιος άλλος. Να το πάρει κάποιος άλλος. Δηλαδή έχουμε τόση ενέργεια για εκατομμύρια χρόνια και δεν την έχουμε. Προτιμάμε να εισάγουμε φυσικό αέριο και λοιπά. Εντάξει.
Thank you all. We have another question. Yeah.
Πείτε μου ιδιαίτερα να μην τους καθυστερήσω.
Η ερώτηση μου είναι απλή. Γεωλόγος είστε, αν κατάλαβα καλά ή όχι. Υπάρχει κάποια συσχέτιση πιθανή μεταξύ περιοχών όπου υπάρχει γεωθερμική ισχύς και εκεί που υπάρχουν υδρογονάνθρακες? Όχι. Τελείωσα.
Thank you all. We're going to the next session. you.